Welcome to this deep dive. Today we're taking a close look at something really vital for keeping your Aurora diesel generator running well for, well, years to come.
That's right.
We're talking about the break-in process. You've made a pretty big investment in reliable power, and understanding this initial phase, it's just key to getting the most out of it, performance-wise.
Absolutely.
So we'll be digging into why these first few hours of operation are so important, what it actually involves. We've got some expert insights, some technical info to draw on.
Exactly. And you can think of that initial break-in, even for an engine that just sits there running at 1800 RPM, like in a generator. Think of it like laying the groundwork for its whole future.
Laying the groundwork. Okay.
Yeah, it's not just, flicking the switch and letting it run. It's about getting those internal parts optimized for years and years of dependable service.
Okay, let's unpack this a bit then. Why can't we just, fire it up and let it go?
Okay.
What's so special about this break-in time?
Well, even though modern manufacturing is incredibly precise these days, break-in still plays a really vital role. It helps achieve peak performance, you get better fuel efficiency, and ultimately it extends the engine's lifespan.
Okay.
Imagine looking at even super smooth metal surfaces under a microscope. You'd still see tiny little peaks and valleys, right?
Sure, yeah.
Those are on the new components, especially inside the cylinders, where the pistons and the rings are working.
So it's about getting those surfaces to kind of mesh together properly.
Precisely. The break-in lets these parts bed into each other. As the engine runs, those microscopic high points, they gently wear down.
Right.
And that creates a much more complete contact area between the parts. This whole process, it's essential for getting a good seal, and really importantly for establishing a consistent layer of oil, of lubrication.
Okay.
And when those surfaces fit together better, there's less friction. And less friction means less wear on those really critical engine parts over the long haul.
That makes perfect sense. Less rubbing, longer lasting. Simple enough. Now, I have heard people say that break-in isn't maybe as critical as it used to be, with older engines. Is there some truth to that?
That's a very good point. Manufacturing tech has advanced, dramatically.
Right.
Today, factories can make engine parts with much, much tighter tolerances, higher precision in how they're made, how they're put together, and they can do it cheaper than they used to.
Oh.
So in some ways, a standard engine you buy today might have a build quality that back then you'd only find in like high-end custom racing engines.
Wow. Okay.
And because of all that, yeah, the recommended break-in times for modern engines are generally shorter than they were for the older machines.
That's interesting. So with all that precision built in, is it possible that maybe some generators like these Aurora units might even get some break-in done at the factory before they even ship out?
Yeah, in some cases, definitely. A manufacturer might do a sort of preliminary break-in right at the factory. And you can see that as a real plus for the customer, for you. The idea that you're getting an engine that's already kind of primed for top performance right out of the box, that's appealing.
Sure.
And it also gives the manufacturer a bit more control, making sure that break-in is done just right, which, can be less certain if it's all left up to the end user sometimes.
Right, ensuring a good start. But what about, those really elaborate, sometimes complex break-in steps you hear about from old-timers or for older gear? Are those still needed?
Yeah.
Or even helpful today?
Well, our understanding of what's actually happening inside the engine during break-in, it's grown a lot over the years.
Okay.
Thanks to better engineering, material science, all that. And this deeper knowledge, it's shown that some of those really long, complicated break-in methods from way back when, they weren't always based on solid engineering facts. Often they came more from, tradition or just stories passed down. Now, if you follow those old beliefs carefully, it probably won't hurt anything. But modern engineering advice, it generally says don't put too much faith in those super complex routines.
So basically, stick to the manual. Stick with what Aurora recommends for their specific generator. That's the way to go.
Absolutely. That's the best advice. And, you might even find some manufacturers still include break-in procedures in the manual, even if they're maybe less mechanically critical than they once were.
How's that?
Could just be to give you comprehensive info or maybe address customer expectations, people who are used to seeing it from past experience.
Gotcha. Okay, so we get why it's important to follow the manual. What are the actual first steps someone should take? They've got their new Aurora diesel generator. What do they do first for break-in?
Okay, so pulling from, general expert knowledge and what you typically find in an owner's manual, there are a few key things right after you first start it up. You'll usually see a specific break-in period mentioned. For instance, some Aurora units might say something like, A 30-hour break-in is recommended.
30 hours. A good number to keep in mind. What's the absolute most important thing during those first 30 hours or whatever the manual says?
One of the most critical tasks, maintenance-wise, during this break-in is changing the lubricating oil and the oil filter.
Ah, that first oil change.
Exactly. It's a specific step. It'll be right there in the service schedule for the generator, listed after a certain number of operating hours. And that initial break-in period, that's almost always when that first oil change is called for.
Makes sense. Get any initial wear particles out?
Precisely. So you need to pay really close attention to the manufacturer's guidelines for that first change, when to do it, and crucially, the exact type of oil and the amount of oil to use. Don't guess on that.
Right. Use the specified stuff, fresh, clean oil early on. What else should people be thinking about in those early stages?
Well, safety first, always. Make sure you're using your PPE, your personal protective equipment, gloves, eye protection, whatever's recommended.
Good point.
Anytime you're doing maintenance, even just checking levels or doing that oil change, also think about where the generator is. Keep it in a clean spot, away from excessive dust, dirt, debris.
Why is this so important?
Because that stuff can get ingested or just generally gum things up and negatively affect engine performance over time. And just get in the habit of regularly checking the oil level with the dipstick. Make sure it's always right on the mark.
Okay, good habits. Now, let's talk about how these generator engines run. Unlike a car, they operate at a constant speed, don't they? Usually 1,800 RPM for this kind of unit.
Exactly. That's a really key difference.
So how does breaking in an engine at a fixed RPM differ from, say, breaking in my car engine, where I'm supposed to vary the speed, avoid high revs, that sort of thing?
Yeah, that's a great question because the process is different. With the vehicle engine, varying the engine speed, like you said, is often part of breaking it in.
Right.
But with the generator engine just humming along at a steady 1,800 RPM, the focus for break-in shifts. It shifts to managing the electrical load you put on the generator.
Ah, the load, not the speed.
Exactly. Instead of varying how fast the engine spins, you want to gradually increase and then decrease the amount of electrical power the generator is actually producing during that initial break-in period.
Okay, varying the load while the engine speed stays the same.
Mm-hmm.
How do people usually manage that? How do you control the load?
A common way, and pretty effective, is to use what's called a resistive load. Something simple like an electric space heater often works well.
Like plugging in a heater.
Yeah. It allows you to control how much electricity the generator has to work to produce. You can turn it on low, then medium, then high, then back down, vary the demand.
Okay.
And while you're doing this load cycling, it's really, really important to just monitor the generator. How's it performing? What's the operating temperature? Listen for any weird noises, watch the gauges, just keep an eye on things.
Got it. Monitor while varying the load. So let's say you've done that initial break-in, you've done that crucial first oil change. What's next? What about ongoing maintenance to keep these diesel generator happy? Right. Because break-in is just the start. Even after it's done, sticking to the manufacturer's recommended maintenance schedule is absolutely vital. That's key for long-term reliability.
Makes sense.
This means regularly checking all the essential fluids, your fuel level, your coolant, the oil level, obviously, and also inspecting things like the air filter, fuel filter, other key parts mentioned in the service schedule.
And what about the diesel fuel itself? Especially for a backup generator that might not run very often. Fuel can sit for a long time.
Oh yeah, that's a big one. If your generator isn't used frequently, you really should treat the diesel fuel with an approved fuel stabilizer.
Okay.
These additives, they help stop the fuel from degrading, breaking down over time. And it's also just good practice to maybe periodically test the stored fuel, make sure it hasn't picked up water or gotten contaminated somehow.
Good tip. Now, sometimes you see discussions online, maybe forums, people talking about adding extra stuff, like upper cylinder lubricants or using magnetic drain plugs to catch metal particles. Are those things generally needed or recommended by manufacturers like Aurora?
You'll definitely find a lot of advice out there online, and much of it is well-intentioned, people sharing their experiences.
Sure.
But honestly, the best approach is almost always to prioritize the break-in steps and the ongoing maintenance that Aurora specifically recommends in the documentation that came with your generator.
Stick to the book.
Yeah, they designed and built the engine. They have the most complete understanding of what it actually needs to perform best and last the longest. Those extra things, usually not necessary if you follow the standard procedures.
Okay, that's clear. You mentioned earlier about the science bit, the piston rings and the cylinder liners needing to bed in. Can you give us maybe a little more detail on what's actually happening there, like on a microscopic level?
Sure. Yeah, it's pretty fascinating stuff. That break-in period, it's really crucial for allowing those piston rings and the surface of the cylinder liner to achieve the best possible contact and lubrication between them.
Okay.
It involves this really complex interaction. It's governed by engine dynamics, how things move, and this field called tribology.
Tribology.
Yeah, tribology. It's basically the science of friction, wear, and lubrication, how surfaces interact when they rub together.
Ah, got it.
So the main goal during break-in is to create this really reliable interface, this connection between the ring and the cylinder wall that gives you a proper seal stopping combustion gases from blowing by and ensures consistent lubrication for the rings.
Okay.
Engineers actually use some pretty sophisticated tools and computer models to analyze all this, things like transient thermoelastohydrodynamics.
It sounds complicated, and it is.
Yeah, sounds it.
It's basically looking at how heat, pressure, elasticity, movement, and the fluid, the oil, all interact right there at that tiny ring liner interface. It's a multi-scale, multi-physics kind of problem.
Mm.
Wow. So all that complexity just to get parts to wear in smoothly. Why was this even more critical way back when, with older engines?
Well, historically, manufacturing just wasn't as precise as it is today, right?
Right.
So early engine pistons and cylinders, they simply weren't made with the same super tight tolerances. There was more variation.
Okay.
And that meant there was a much greater need for an initial running period to allow these, let's say, slightly less perfectly matched parts to wear against each other and create that good seal, to seat properly.
So the break-in was doing more of the fine-tuning back then.
Exactly. Modern manufacturing, with its incredible precision, has significantly...
So it's still a vital refinement process, just maybe happening faster or on a smaller scale than before. That really does highlight why understanding and, actually following those recommended break-in steps for your Aurora diesel generator is still important.
Absolutely. It really is about giving your generator the best possible start in life. You want it to have a long, dependable service life, right?
Definitely.
So taking that little bit of extra time and care at the beginning, understanding the why behind the break-in, following the guidelines, you're basically making a smart investment in the long-term reliability of your power system.
So as you can see, that initial break-in for your diesel generator, it's a really critical step. It basically sets the stage for how it's going to perform and how reliable it'll be down the road.
Mm-hmm.
By understanding the principles, what's actually happening in there and sticking to the recommended procedures, you really are investing in the long-term health of your generator. If you want to explore diesel generators more, maybe check out the options, visit our website at www.auroragenerators.com.
Good place to look.
Now, here's maybe a final thought to leave you with until next time. Think about your generator not just as this, chunk of metal, but as a system that really benefits from a careful, considered start. Kind of like tuning a musical instrument before a performance, maybe.
That's a good analogy.
So what other seemingly simple maintenance steps, things we might overlook, could actually have a surprisingly big impact on how long our important equipment lasts? Something to ponder? We'll catch you on the next deep dive.